Okay, now let's run this multi-class logistic regression using M binary classifiers. Let's just run this thing. And I'm going to pause as this runs along. So unfortunately, the first one is already incorrect. MNIST thinks it's 2, of course. It looks like a 2. Our classifier, best guess, actually looks like a 3. The second best guess, in fact, is a 2. That's interesting. Okay. Here, it's a 3. Our classifier thinks it's a 3. Second best guess is a 5. It kind of looks like a 5. That's interesting. It's a 0. We think it's a 0. Second best guess apparently is an 8. Gets it right. Again, right. Correct. 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 Again, correct. 1 and 1. 0 and 0. 5 and 5. Etc. Right? So, well, here, for instance, again, another little error. MNIST, of course, thinks it's a 2, but our classifier thinks it's a 3. But the second best guess, the classifier with the second best z value was in fact 2. Okay, so that's interesting. Unfortunately, we cannot really assign probabilities for these guesses, um, at least in a meaningful way, in a satisfactory way. Okay, but looks overall pretty good. We can check. Let me just Control C out to see. Um, yeah, so I guess that's a nice little demonstration. I think the error rate is about 80. The accuracy is about 80-90%, 80 to 90%. Maybe I'll leave this as an exercise for you guys to check what the accuracy of this classifier is. But it looks like we got it right about 8 or 9 out of 10 times. Okay, so that's it for this little method. Like we said, it doesn't necessarily report a satisfactory probability of its sort of confidence for each image in a satisfactory way. So we will next talk about a second approach, which does a holistic job rather than doing independent binary classifiers. It sort of uses all the data to classify uh, a data point into one of how many of our classes. Okay.